Alright, so this was number 2 from chapter 3, section 3. So if I'm trying to find out what this is equivalent to, what is it equivalent to, I could first rewrite what the cube root of 4 is, which is 4 raised to the 1/3. So thinking about how logarithmic and exponential functions work together, how they relate to each other, you take this base of 4 to your exponent equals what you're left, this piece. So then I have a one-to-one property. My bases are the same, so my exponents are equal to each other. X equals the 1/3. You could also use the power rule that it talks about. So if I have something like this, I know that 1/3 could come in front. That's using the power rule because this becomes a product. And then what is log base 4 of 4? Well, again, 4 to the what power equals 4? Well, x would have to equal 1. So I just get 1/3 times 1, which equals your 1/3. Either way you do it, you get 1/3 for number 2. Another one that they had was an expansion one that we looked at. I believe it was number 10. And so on number 10, it had this big old thing, natural log of z plus natural log of z plus 9 minus 4 times the natural log of z minus 9. So order of operations are still in effect. You would want to combine these first, and so going backwards from the product rule of logs, you know that this was just once natural log of z times z plus 9. Using that product rule with the power, this is now just natural log of z, I guess I could multiply it out, 9z, all of that raised to the 8th power. The subtraction part, using that power rule, that product rule, power rule, sorry, is z minus 9 raised to the 4th. And so I'm subtracting these two pieces. They have the same base. They're both natural logs. That's log base e, log base e. So I can combine them when it's with a subtraction and make it a division problem. So I have z squared plus 9z raised to the 8th, and on the bottom I have this raised to the 4th. So this would be my piece, my final answer in a condensed form. So they gave me expanded form, and I condensed it down to something nicer. This is going to help us when we start solving in the next section.